So we know that atherosclerosis is the main contributor to coronary artery disease, and in the coronary arteries, atherosclerosis will cause buildup of these fatty cholesterol-filled plaques. Like so, you can see me drawing them in here, and they're occurring all over the coronary arteries. So what they do is they sort of obstruct blood flow down the length of the coronary arteries and through all the branches of the coronary arteries, because they're just these big bulges of fat that are in the way. So how do they develop? What exactly is this process of atherosclerosis? Well, let me show you what this looks like in a snapshot before we actually look at the mechanisms. So I'll take this piece of coronary artery here, let's say this piece right there, and we'll blow that up. So if we look at that, and when it's nice and healthy, right, it's going to look like this. So here's our healthy blood vessel, nothing built up inside, and so you can see blood is going to flow through this way, right? And this here is a cross section of the artery. So, as far as we can tell, blood can flow smoothly and nicely through this blood vessel, no obstruction, everything looks good. But when you start getting atherosclerosis happening, things can get a little bit different. So when you start getting atherosclerosis happening, your coronary artery might start to look something like this. And so immediately, we can see that there's a pretty big difference between the first vessel here, the nice clean one, and the second vessel here, the atherosclerotic sort of fatty plaque vessel here. All this yellow stuff is some gross fatty plaque that's been deposited into the vessel wall. And if we look at the cross section here, we can see that it's really doing a number on the amount of blood that's able to flow through this vessel, right? And so if we're blood here in red, we can't actually get through this vessel quite as much as we could through here. Look how much room we had in this one. And so this is why, because of all this buildup, this is why we're going to get downstream symptoms. How exactly does this happen? Well, let's redraw our own arteries so we can go through it step by step. So here's our blood vessel there, and now I'm drawing the 3 layers of the wall of the blood vessels. And on the very inside of the blood vessel, as part of this pink layer here, we have a single layer of cells called the endothelium. So let me just draw out the endothelium here. And although it's just a single layer of cells thick, the endothelium has a lot of really important roles. One of its really important jobs is to act as a barrier. And it acts as a barrier between stuff that's in the blood and the rest of the blood vessel wall. So stuff can't just pass through and get into the rest of the blood vessel wall. And this barrier function will become pretty relevant in a minute. You'll just have to take my word for it for now. And another really important job that the endothelium has is to secrete proteins onto its surface that prevent clotting, that keeps blood flowing nice and smoothly. So those are 2 of its major jobs. It has a couple more, but those are the ones that are relevant in atherosclerosis. Alright, so you remember that big fatty vessel from before. Well, how do we get from this, our nice clean blood vessel, how do we get from this to that? Well, let's take a look. Well, the first thing that has to happen is that there has to be some irritant present. Something in the blood that's going to predispose this atherosclerosis to happen. So what are some irritants? Well, things like too many lipids, so specifically fats and cholesterol, LDL cholesterol, the bad cholesterol. And let's actually put some of this cholesterol in the blood vessel so we can just see it really clearly. And I'll just label it LDL, LDLC actually, so you know this is cholesterol, LDLC. Another irritant, probably the worst one, is toxins from cigarette smoking. So we'll put some toxins in the blood from cigarette smoking. We'll do them in gray here. And another major one is just hypertension, high blood pressure. So we'll try to show that pathologically high blood pressure here by these arrows. High blood pressure. And this means high blood pressure. And I'll actually write hypertension here because I just want to make it clear that it's the chronic exposure to high blood pressure. It's not just, high blood pressure every once in a while. So that's our first step, to have an irritant present. And our second step is to actually have damage to the endothelium by the irritant. And so our barrier now is broken down. It started to break down. So that's step 2. That's actual damage of the endothelium. And in step 3, regardless of whatever damaged the endothelium, I mean, if it was toxins or if it was the cholesterol or if it was the high blood pressure, regardless of what actually damaged the endothelium, what happens next is that the cholesterol will jump in there and start to collect under the damaged endothelium. So let me actually clear away some of this because we're going to focus on the cholesterol now. So this is cholesterol, and it's going to sort of settle in here. It's going to think to itself, hey, that looks pretty comfy. That looks like a cozy place to be. So I'm going to just jump in there. And of course, these are coming from inside the blood, right? They're not just sort of multiplying. They're floating around in the blood, and then when they come across this damaged endothelium, they're going to join their friends. And when they build up to this sort of flattened extent here, they're known as a fatty streak. So one thing that happens to the cholesterol when they get inside the wall of the blood vessel there is that they start to get oxidized. They sort of change a little bit. And when they change, when they get oxidized, that sends a signal to the immune system, to our body's immune system. And that signal will bring around these cells of the immune system called monocytes. So they'll sort of show up almost like police. So here's a monocyte here, and I'll draw it in white to remind you that it's a white blood cell. And this monocyte doesn't really like that the cholesterol is starting to collect in the blood vessel walls. So the monocyte will actually chase in after the cholesterol to try to break up the little party that they're having. And so I'll actually draw what happens next down in this next bit of the blood vessel down here, just so we can keep in mind all of the past events. So you may have noticed that I drew this white blood cell to look like a Pac-Man sort of thing, eating up this cholesterol, because that's essentially what it does. Once it gets into the endothelium, it converts into something called a macrophage. Macro meaning big, and phage meaning to eat. So it's really this big eater its job here is to devour that LDL cholesterol that's collected in the endothelium. Unfortunately, things don't go as planned for our macrophage, because what ends up happening is it starts to gorge itself. The macrophage eats so much cholesterol that it just sort of becomes too full of these yellow cholesterol drops, and it sort of dies off. But it's full of cholesterol, and someone a long time ago looked down a microscope and thought that these dead macrophages filled with cholesterol looked like foam, like sea foam that you see at the beach. So these dead macrophages filled with cholesterol are now called foam cells. So let's catch our list up. And remember, these foam cells were actually white blood cells. So when they die, they release these signals that sort of call in reinforcements. And I'm going to use that to remind you that atherosclerosis is primarily an inflammatory disease. It's an inflammatory condition. And so when these foam cells release their cytokines, their signals, they call in reinforcements, and the whole process sort of proceeds in this vicious cycle, as you'll see. And don't forget that LDL is also still being deposited into the wall from the bloodstream. And as part of this inflammation, more and more endothelial cells get damaged. So I'll move our drawing down even further so we can look at the next sort of development. And so you can see this mountain of cholesterol and foam cells, dead macrophages that are filled with cholesterol. You can see this mountain just keep on building and bulging out into the middle of the blood vessel. And so by now things are just way out of control, right? And these guys in here, this is the smooth muscle part of the artery, by the way. So this is the smooth muscle layer. These guys start to take notice, these smooth muscle cells. So what ends up happening is that you get smooth muscle cells that sort of migrate out of the smooth muscle layer, and they sort of migrate. I hope you can see this. I'll draw them a bit thicker. They start to migrate out of the smooth muscle layer and into the fatty plaque here, right? Because they can sort of sense that something's just not quite right. And what they start to do is they really want the plaque covered up, because they don't want the thrombogenic, remember thrombogenic means clot forming, they don't want the thrombogenic plaque to be exposed to the blood. So what they start to do is they start to secrete a fibrous cap. They sort of spit out this collagen and elastin protein cap that covers up, right? So I'm drawing it in purple, that covers up this plaque and shields it from the bloodstream. and that's called a fibrous cap. And they also do something else. The smooth muscle also do something else. So you remember these foam cells that died in here? Well, when they release their signals after they die, they induce the smooth muscle into depositing calcium into the plaque. So I'll draw that in. I'll draw in these little calcium crystals now. So you can see it's just starting to look like a mess in here. There's just all sorts of stuff going on. So again, this is really not something you want to have happening in your body. And so just by looking at this, what can we say is happening to the blood vessel? Well, I mean, we can see this huge bulge. We can see that the plaque is obviously bulging into the blood vessel, and it's probably going to restrict the flow of blood that can get through here. So that's one thing that atherosclerosis is doing. It's occluding, it's blocking off the arteries. The second thing is, well, look at this calcium. I mean, if there's one thing we know about calcium, is that it's really tough, it's really hard. And so this by the smooth muscle laying down calcium, that's one of the ways that atherosclerosis makes your arteries really hard. And that's actually part of the name. Atherosclerosis actually means hardening of your arteries. But I think in terms of coronary artery disease, the biggest reason that atherosclerosis is bad is because it can cause complete blockage of the artery. And that blockage of the artery can happen because sometimes this plaque, this fatty plaque, it can rupture. And when it ruptures, all this thrombogenic plaque material gets exposed to the blood. And when it gets exposed to the blood, it starts to form this really big blood clot in the middle of your artery, in the middle of one of your coronary arteries. So let's just draw that in here. Let's just draw this big blood clot. Pretend that this has been ruptured and this yellow thrombogenic material has been exposed, and this big blood clot's going to form. By the way, I'm originally from Jamaica, and blood clot is a bad word in Jamaica, so I apologize to any of my Jamaicans who are watching this. So this big clot could form, and it could totally block off the blood vessel. And when that happens, no blood can get through, right? So this is really the biggest reason that we don't want atherosclerosis to be happening in our coronary arteries, because you can see that we've blocked off the blood flow, and if blood isn't allowed to get past this clot and get to the piece of the heart that it's supposed to be serving within about 20 minutes, then you get irreversible damage and death of that piece of heart muscle. So for example, what we drew was this little piece of artery here, right, in blue. So if a atherosclerotic plaque and a clot developed right there, as it has in our vessel here, then that would be really, really, really bad, because, you know, all the blood for this whole part of the heart is coming from this upstream vessel. So without getting blood flow through this vessel for about 20 minutes, if this clot sort of persists for about 20 minutes, all of this heart muscle would start to die off. So that would be a massive heart attack. And actually, let me just clarify. So we say heart attack, but in medicine, we refer to a heart attack as a myocardial infarct, or an MI. So myocardial just refers to heart muscle, cardia for heart, and myo for muscle. So heart muscle. An infarct means death of tissue due to lack of oxygen from lack of blood. So a myocardial infarct is death of heart muscle due to lack of oxygen. So here we've had a myocardial infarct due to this big plaque that developed here.